Okay, grade 8, moving on. Now we are going to discuss how to calculate mechanical advantage for levers. Now you have already done levers in the previous sections, so just go over those sections before you begin with this. Okay, so we are going to discuss how to calculate mechanical advantage. Let's look at a few keywords that we need to know before we begin. The first one is ratio formula. Ratio formula is used to calculate mechanical advantage by using the effort arm and the load arm. Okay, so this is the ratio formula that we are going to be using. It is very important for you to write down and to memorize. Okay, the effort arm is the distance between the fulcrum and the point where the input effort is being applied. So here in this example, this will be the effort. It is the distance between the fulcrum and the point where the effort is being applied. Here's the load arm, the distance between the fulcrum and the point where the output load is being applied. So here's the load arm, the distance from the fulcrum to the point where the output load is being applied. Okay. Now, one thing you will notice when we begin with our calculations is in a mechanism where the fulcrum is closer to the effort, the mechanical advantage will be greater. Okay, when the fulcrum is closer to the effort. Okay, right. Let's begin with our calculations. So if you look here, this is the formula that we are going to be using. Now, the formula states that mechanical advantage equals the length of the effort arm over the length of the load arm. So you just need to substitute the measurements into this formula and you will get your answer, right? So let's look at an example. Here is a person trying to lift up a rock, okay, with a short stick. Okay, can you identify the effort, load, and fulcrum? Here's the effort, here's the fulcrum here in the middle, and here is the load. Now, here is the effort arm, the different distance between the fulcrum and the point where it is being applied. So the distance of the effort arm is 0.4 meters. Here is the load arm. The distance, here's the fulcrum, so it is the distance from the fulcrum to where the load is being applied. The distance of the load arm is 0.5. So let's put it into our formula. Firstly, we write down the formula. The length of the effort arm, 0.4. We put it in our formula. Length of the load arm is 0.5. We put it into our formula. You will do this calculation. You will be allowed to use a calculator and you will see that your answer is 0.8. Okay, that is your mechanical advantage. Now, as you can see, mechanical advantage is less than 1. Okay, because 0.8 is less than 1. Okay, now let's do the calculation for the long stick. Here is the long stick. Now, remember that. Okay, so here's the calculation with the long stick, okay? Let's look at the distance of the effort arm. It is 2 meters. The distance of the load arm is 0.5. So we are going to say, write on our formula and put in our distances. So the length of the effort arm was 2 and the length of the load arm was 0.5. You put that into a calculator and you will get the answer 4. As you can see, mechanical advantage is greater than 1 here. So it will be better for us to use the longer stick. Okay, a mechanical advantage of less than 1 does not mean that the stick is useless. It simply means that instead of multiplying force, the stick multiplies distance. Okay, the gardener should use the longer stick because it offers more mechanical advantage. Now, from this calculation, we can say that the greater the distance from the fulcrum to the effort, the greater the mechanical advantage will be. Okay, you guys are going to do this activity for me. Let me know if you need any help.